Introduction to lighting in Corona and types of lights. 1. Importance of environment light. In Corona Renderer, environment light is one of the most essential light sources. This type of light helps create natural illumination in the scene. Even in studio or product lighting, this light is necessary. In both interior and exterior renders, environment light should always be configured for realism. 2. Artificial lights in Corona. In Corona Renderer, artificial lights play a significant role in scene illumination. Corona provides Corona light, which includes various types of light sources: sphere light, rectangle light, disc light, cylinder light. Additionally, users can add IES light within Corona light, useful for creating focused and specific lighting effects. 3. Understanding global illumination (GI) and its role in lighting. Global illumination (GI) is a computational process, not an independent light source. GI calculates how light spreads and interacts with materials in a 3D environment. With GI enabled, lights behave more realistically in relation to surfaces and materials. In different rendering engines, such as V-Ray, Octane, Corona, and Lumion, GI principles remain the same. Users who understand GI can easily switch between rendering engines. Understanding global illumination GI in Corona and its impact on lighting. 1. How GI works and the role of light bounces in a scene. Global illumination GI is one of the key lighting systems for realistic rendering. Primary light sources emit rays from the camera, interacting with scene surfaces. After hitting surfaces, lights bounce and reach the viewer's eyes, forming the final image. If GI is disabled, light rays do not bounce, resulting in an unrealistic scene. 2. Difference between GI in Corona and V-Ray. In V-Ray, GI settings include multiple methods such as irradiance map, light cache, and photon mapping. Users in V-Ray can manually adjust GI processing methods. Corona automatically handles GI, eliminating the need for manual adjustments. Corona's default settings use path tracing for primary calculations and UHD cache for secondary processing. 3. Impact of GI settings on render quality and performance. GI increases computational load, but is essential for realistic renders. Disabling GI removes accurate shadows and degrades image quality. For interior renders and closed scenes, keeping GI settings at default is highly recommended. Tests show that light cache can improve processing quality in 3D models. However, Corona's default settings usually deliver the best results, so significant modifications are not necessary. Adjusting AA balance and managing noise in Corona rendering. 1. Role of AA balance in controlling pixel quality. AA balance, anti-aliasing balance, directly affects the clarity of rendered pixels. In initial render passes, some pixels may have noise, especially when zooming in. Increasing AA balance helps prevent pixel distortion and improves sharpness. Older display technologies showed similar pixelation issues when zoomed in, and this phenomenon appears in early rendering phases as well. 2. Setting AA balance based on lighting conditions. In Corona Renderer, AA balance is preset to 16, which works well in most scenes. If the scene contains excessive artificial lighting, strong noise artifacts may appear. To counter this, increasing AA balance up to 32 enhances render quality. The maximum recommended value is 64, and the minimum should never go below 4. For scenes with numerous indirect light sources, setting AA balance to 32 or 64 may be beneficial. Conversely, for simpler scenes, values around 8 or 16 may suffice. 3. Impact of sample intensity in night renders. Sample intensity adjusts the clarity and precision of light sources within a scene. In night renders, increasing sample intensity improves light glow visibility. For an accurate point light display, this value can be adjusted accordingly. Maintaining a balanced sample intensity prevents unnecessary noise buildup. In complex lighting setups and nighttime renders, configuring sample intensity properly is essential for achieving high-quality results. Light samples settings and their impact on render quality. 1. Evaluating light samples and its effect on noise. Light samples is a key parameter in Corona's lighting settings, directly influencing image noise levels. Lower light samples, for example, 16 increases noise but speeds up processing. Higher values, for example, 64 reduce noise but prolong render time. The optimal range is typically between 16 and 32, depending on scene complexity. 2. Comparing light samples and light sample multiplier. Analysis has shown two crucial values affecting render performance. Setting light samples to 16 right arrow more noise, faster processing, 9 min. Setting light samples to 64 and light sample multiplier to 0.25 right arrow minimal noise, longer processing time, 24 min. Setting light samples to 32 and light sample multiplier to 0.125 right arrow, a balanced approach between quality and speed. 3. Choosing the best render settings. If the scene contains numerous light sources, set light samples to 32 or 64. For balanced settings, use 16 and set light sample multiplier to 2. For quick render tests, lower values, a 16 and 0.5. Reduce processing time, but introduce more noise. Managing noise in artificial lighting and choosing optimal render values. 1. Impact of different settings on scene noise levels. Tests show light samples and light sample multipliers significantly affect render noise. Setting 16 and 2 right arrow moderate noise, shorter render time. Setting 64 and 0.25 right arrow minimal noise, longer processing time. Setting 4 and 1 right arrow high noise levels, faster processing. For final renders, 16 and 2 is typically the best balance between quality and speed. 2. Managing noise in heavy scenes. If working on a lightweight scene with a lower-end laptop, light samples can be reduced to shorten processing time. Remaining noise can be corrected in post-production or using a denoiser. Lowering noise settings in quick renders can decrease rendering time by 5 to 6 times. For scenes requiring high output quality, adjusting light samples is essential. Interactive rendering settings and caustics effect in Corona. 1. Setting limits in interactive rendering. In Corona Renderer, when activating interactive rendering, users can set pass limits. If set to 3 passes, rendering stops automatically when reaching this limit. Setting it to 0 allows rendering to continue indefinitely until manually stopped. This feature helps optimize system performance and processing speed. 2. Role of denoiser in close-up renders and material testing. When testing renders in interactive mode, denoiser can quickly reduce noise. If enabled, noise is instantly removed, but material details might be compromised. For close-up tests, for example, examining wood textures, denoiser should be disabled for better clarity. 3. Evaluating caustics and its role in realistic lighting. Caustics is an essential effect that simulates light refraction and reflection. When light interacts with transparent surfaces, such as water or glass, caustics calculations determine how light disperses. If caustics is enabled, complex reflections occur, allowing realistic effects such as rainbows. 4. Using caustics in specific renders. In water-based scenes, caustics enhances realistic light refraction. In architectural renders, it improves natural light reflections from windows and glass. For scenes without transparent elements, disabling caustics speeds up processing. Animation rendering settings and frame management in Corona. 1. UHD cache settings for still frames and animations. In Corona Renderer, UHD cache settings differ between still frame rendering and animations. For static renders, UHD cache should remain at default settings. In animations, each frame requires recalculated GI, so animation frame by frame must be enabled. This setting prevents flickering and ensures smooth GI calculations across multiple frames. 2. Frame buffer settings and choosing the best option. Corona frame buffer is the preferred option for viewing render outputs. If none is selected, the frame buffer won't display. If Corona VFB is enabled, users gain full access to light, shadow, and color adjustments. Standard practice is to always use Corona VFB, since 3ds Max's frame buffer lacks advanced features. 3. Using image filtering for enhanced quality. Image filtering significantly impacts image sharpness. Tint is recommended for use with denoiser. If image filtering is set to high quality, denoiser won't function optimally. 4. Exploring elements and using separate render outputs. Corona elements allow users to render different aspects of an image separately. Reflection pass for isolated reflections. Alpha channel for transparent backgrounds. Light elements for individual light outputs. These features are highly useful in post-production and render layer blending. Rendering and realism in Corona Renderer. In this session, we explored various rendering techniques to enhance realism in Corona Renderer. First, we adjusted the CGT Extras effect using Corona AO materials, ensuring that ambient occlusion calculations were accurately processed. This technique allows shadows in surface contact areas to appear more natural and realistic. Similarly, we examined normal mapping, which plays a crucial role in selecting surfaces for 3D modeling and proper path creation. Next, we reviewed diffuse mapping, which helps refine material selection. We then moved on to light mix, an incredibly useful tool for adjusting light intensity without needing to re-render. After discussing global illumination, GI, we realized its significance in interior and exterior lighting setups. However, due to its complexity, we postponed the deeper analysis to the next session. Okay, we have reached the end of this session, and we covered all the important points. Be sure to practice and repeat these features so that you are prepared for the next session. I am Behrouz Bigham from the Architecture and Graphics Simulation Studio. Have a good day.